Alright, so this video we're going to talk some more about logic, compound statements, and connectives. It's not really difficult, as you know, you just got to know what each of them mean. So let's go ahead and get started. So here we have, if P and Q represent two simple statements, then the compound statement P and Q is symbolized by this. Okay, it's just like the little caret on the keyboard means P and Q. The compound statement formed by connecting statements with the word and is called a conjunction. And the symbol for and is, and this is your symbol here for and. All right, so let's go ahead and look at an example. It says, let P and Q represent the following simple statements. P represents the statement it is after 5 p.m. Q is the statement they are working. Write each compound statement below in symbolic form. All right, so it is after 5 p.m. and they are working. All right, so you can see here this it is after 5 p.m. that represents the statement P. And they are working, this statement here, see, they are working, that represents statement Q. And the and here, this and represents that symbol there. Okay, see that, remember that's from up here, and is this symbol. And so to write this, that would be P and Q. All right, so what about B? It is after 5 p.m. and they are not working. So this one represents the statement P and represents our symbol. They are not working. All right, well, Q is they are working. So this is they are not working. So this is not Q. So if you remember from the previous video, the symbol for not is that little tilde symbol. Okay, so in symbolic form, this would be P and not Q. Okay, so there's the answer for B, and there's the answer for A. All right, so we've got common English expressions for P and Q. So what this is getting at is it's not going to always say, like in that previous example, this and this. See, like this one right here. This right here is P and Q. This is symbolic form, and this is how it would look, P and Q. That's what this means, P and Q. And if we use the two statements above, the P and the Q, it is after 5 p.m. for P and they are working, we use that for Q. Then the way this would look is it is after 5 p.m. and they are working. That's how you would write this out right here. All right. Now, some other options to write these things out, it may not always be and in between them. But notice this is P, the and symbol, Q, that's all of them here, okay? And other ways that you can express that is not just P and Q, but you can do P but Q, and that would read as it is after 5 p.m., but they are working. Okay, so if you had it is after 5 p.m., but they are working, then symbolically you could do that P and Q here. Okay, and then you also have P yet Q. It is after 5 p.m., yet they are working. So that could be written like this symbolically. And then you also have P nevertheless Q. It is after 5 p.m., nevertheless they are working. All right. So, and this would be a semicolon. So it is after 5 p.m., nevertheless they are working. That can also be expressed symbolically as P and Q. So this right here is kind of like three columns we have here, like this. Okay. So not just separating, to use this notation here for symbolic, it doesn't have to necessarily just be and in between them. It can be and, but, yet, nevertheless. Okay? All right. So now let's look at the connective or. So we're talking about or, not instead of P and Q, we'll talk about P or Q. All right, so the connective or can mean two different things. Exclusive or, which means one or the other but not both, and inclusive or, which means either or both. So what they're saying, exclusive, like it's like if you have two things, like you have two statements, P and Q. Either P is going to be true or Q is going to be true. And that's it. But not both of them are going to be true. That's what exclusive or means. Inclusive or means P can be true, or Q can be true, or both of them can be true. That's inclusive. And in mathematics, when the connective or appears, it means inclusive or. So whenever you see the connective or in between them, P and then or, this right here, Q, that's going to mean this one right here. Okay, there's another symbol for exclusive or. This book doesn't do it, but it looks like this, a circle with a plus through it. But don't worry about that. Just know that in this book, in contemporary math, you're going to be dealing with just the inclusive or. It's P can be true, or Q can be true, or both of them can be true. That's the ones we'll deal with. All right, so the symbol for or is this. Okay, so remember, and was this one, or is this. It's upside down. Okay, thus we can symbolize the compound statement P or Q or both, okay, which is the inclusive or, by P or Q. All right, so let's look at another example. All right, so we have, let P and Q represent the following simple statements. The bill receives majority approval. Okay, that's statement P. Statement Q, the bill becomes a law. So write each compound statement below in symbolic form. All right, so the bill receives majority approval. So this statement here is P. And then here we have or, so that's our or symbol. And then the bill becomes a law. See, the bill becomes a law, that's Q. So this would represent the statement Q. And so to write this symbolically, that would be P or Q. And this would be your answer here. And then the same thing here, the bill receives majority approval, or the bill does not become a law. So the bill receives majority approval, that would be P. Here's your or statement. There's your symbol for or. And the bill does not become a law. So that's does not. Here, notice Q, the bill becomes a law. But this says the bill does not become a law. So this is not Q. So symbolically, P or not Q. And that would be your answer there. All right. So hopefully all this is making sense. All right, so let's look at if then. All right, so the compound statement if P then Q is symbolized by P, and then this symbol here is just an arrow, Q. Connecting statements with if then is called a conditional statement. The symbol for if then is this. This is your symbol for if then. All right, the statement before the symbol is called the antecedent, and the statement after is called the consequent. Okay, and I misspelt it here, didn't I? Okay, so you've got the antecedent and then the consequence. And you may have heard it elsewhere, the if then, where this, the first part before the arrow, is the hypothesis and this is the conclusion. Okay. All right. So let's look at at an example. So let P and Q represent the following simple statements. All right. So statement P, a person is a father. Statement Q, a person is a male. Write each compound statement below in symbolic form. All right, so if a person is a father, then that person is a male. All right, so this right here is P. Then that person is a male. That person is a male. That is Q. And then the then here, there's your symbol. So this would be P, Q. All right, so this would be your symbolic form. All right, so what about this one? If a person is a male, then that person is a father. All right, and note that, actually, let me redo this right here. A person is a father, and then the then and the if, that represents that symbol, the if then. All right, so here we have a person is a male, so that's statement Q. See, that's from up here, that's Q. That person is a father, that's statement P, and then the if and then the then, that's represented by this symbol. So that would be Q and then our symbol P. So if Q then P is what that means. All right, so what about this one? If a person is not a male. Okay, a person is not a male. Okay, so Q, a person is a male, but R says is not a male. So that is not Q, and then that person is not a father. Well, you can see P, a person is a father, but we have a person is not a father, and so this would be not P. And the then and the if, that represents our symbol. So we would have not Q, our symbol, not P. And there's your answer. All right, so once again, just like with the and, we have some common English expressions for if P then Q. So let's look at those. And this is like, once again, we've got 3 columns here. So this is the symbolic statement, the English statement, and then here's an example. And so just remember, in this, P is going to represent a person is a father, and Q is going to represent a person is a male. All right, so these are the different ways that you can express if P then Q. See how we have the symbolic here? So we can say if P then Q. We can say Q if P. P is sufficient for Q. Q is necessary for P. P only if Q. Only if Q, P. Okay? All of these can be expressed like this symbolically. Okay? It's not only this one, if P then Q. This will be one of the more common ones that you'll see though. So here's your examples. If a person is a father, then that person is male. Okay, so we did that one in the example. And then we've got Q if P. So here's your Q statement. A person is a male if, see the if, that person is a father. And then we have being a father is sufficient for being a male. Okay, that means this. Okay, and then we have being a male is necessary for being a father. A person is a father only if that person is male. And only if a person is a male is that person a father. All right. So that's just the different ways that you can express this if P then Q. But like I said, a lot of the times, I would say the majority of the time you'll deal with this when it'll have if, the statement, then another statement. Okay. You may come across these some, and if you do, if something looks like one of these, then you know that's what it means symbolically, this over here. All right. So let's look at an example. So it says, let P and Q represent the following simple statements. P is the statement we suffer huge budget deficits. Q, we control military spending. With the following compound statement in symbolic form, or write. Write the following compound statement in symbolic form. So, controlling military spending is necessary for not suffering huge budget deficits. Okay. All right. So how are we going to rewrite this one? All right. So don't get confused with this one. So we just went over that table earlier. All right. So notice here, see, being a male is necessary for being a father. That's what we have here. You see that? See, this is necessary for this. Okay? So, if you look at this, being a male is necessary for being a father. So you see the necessary part is for being a father. See, that's the first one. That's P. See, this is P, and then this is Q. You see that? It looks like they're kind of backwards. So don't get this messed up. Okay? See, the part after necessary, the statement after necessary for, that's first. And then the statement before is necessary for, that's before, that's Q, that's after the symbol. All right. So, I mean, if you wanted to, you could write this back as a if-then statement, but see here, not suffering huge budget deficits. Okay, so see here, suffer huge budget deficits. Well, it's not suffering, so this would be the not P part, right? And then if you look at this part, that's Q. And so what would this look like? This would be what? Not P and then Q. So if not P, then Q. So another way that you could write this is you could actually write this as if we do not suffer huge budget deficits, then we control military spending. That's another way that you could look at this statement right here. Okay, they both mean the same thing. All right, but just like I said, familiarize yourself with this chart here. Notice which ones come first. Okay, like this one, the Q came first, but it is P, the connective, and then Q. Same thing here. See how the Q statement comes first, and then comma, then a P. Okay, so notice that. And then also up here, Q if P. See, the Q comes first over here when it's red, but it's after the connective, and the P comes second, but it's before the connective. So just familiarize yourself with that. All right, and then we have the compound statement P if and only if Q is symbolized by this. Okay, this is called a biconditional statement. The symbol for if and only if is this. It's just a line with an arrow on each end. Okay, that's your biconditional. Now, a biconditional, okay, a conditional statement is true, but reversing the two statements, the antecedent and the consequence, may result in a statement that is not true. Okay, so for example, if you have something like this, you could have if a person is a father, then that person is a male. And then we could reverse that. If a person is a male, then that person is a father. Okay, so while this statement over here would be true, this one over here is false. Okay, so if a person is a father, then that person is a male. That would be true. If a person is a male, then that person is a father. That's not necessarily true. A person can be a male but not have any kids, so they're not a father. Okay, so if you reverse if and only if statements, both of them may be true, or one may be true, one may be false. But, and like I said, some conditional statements, when you reverse them, they can both be true. So for an example, and I'm not going to write it down, if a person is an unmarried male, then that person is a bachelor. So if the person is unmarried, then that means they're a bachelor. And if we reverse that, if a person is a bachelor, then that person is an unmarried male. You can see when we reverse them, then that both of them are true. It's true in that case, both of them are true, but when we reversed these, that was not true. All right. So what we can do is they're both, like in that one I just stated, unmarried male, then is a bachelor, or if he's a bachelor, then is unmarried male. We can combine those, okay? And rather than deal with two separate conditionals, we can combine them into one biconditional statement. So this is your biconditional statement, P, and then the symbol Q. And what that means is you can read it, if P, then Q, if Q, then P. Okay, so remember when we had this P, if P, then Q, and all we're doing here, if P, then Q, and then we're reading it back the other way too, if Q, then P. All right, and what you'll learn in the next section, or the section after that, that you'll learn how to determine when these things are true or false. Okay, and for biconditional, they have to be true both ways. Okay, in order for the biconditional statement to be true. All right, so all this is, instead of writing the statements P, Q, and then writing it separately, we're just writing this. Okay, so let's look at our example. So let P and Q represent the following simple statements. The word is set. Okay, now I mean, and this is actually the word that they're talking about. Like they could say the word is animal, or the word is house. They're just using set here. That's the word that they're talking about, set. And the word has 464 meanings. Okay, so statement P, the word is set. That's the word. And then Q is the statement, the word has 464 meanings. Write each compound statement in its symbolic form. All right. So it says the word, I left out, didn't write it all. The word is set if and only if the word has 464 meanings. All right, so the word is set, that's P. The word has 464 meanings, that's Q. And then we've got our if and only if, there's our symbol. And so symbolically, it would look like this. All right, so what about this one? The word does not have 464 meanings if and only if the word is not set. All right, so the word does not have 464 meanings. Well, that's Q, but we have the not here, so that's not Q. And then the word is not set. Well, P, the word is set, but it says not set, so this would be not P. And then we have our if and only if, and that would be our symbol. So this would be not Q, if and only if. If and only if, not P. And so that would be symbols. That would be it in symbols. All right. Now what do we got? Common English expressions for P, if and only if, Q. All right, so let's take the statements. P is the statement, a person is an unmarried male. Q, a person is a bachelor. All right, so this is going to split up. Into 3 columns again. So let's see, we've got this. All right, and so just like before, we can look at this. So the symbol here, okay, notice they're the same all the way around. There's different ways that we can say it. We can do P if and only if Q, which that's what we just saw. That's going to be the more common one. So a person is an unmarried male if and only if that person is a bachelor. Okay, remember your statements P and Q up here. And then we have Q if and only if P. A person is a bachelor if and only if that person is an unmarried male. All right. And then if P, then Q, and if Q, then P. That's kind of what I explained up here. See, when I wrote this, see, if P, then Q, and if Q, then P. We can just write it like that. All right, so that would be if a person is an unmarried male, then that person is a bachelor. And if a person is a bachelor, then that person is an unmarried male. And then we have this necessary and sufficient. P is necessary and sufficient for Q. Being an unmarried male is necessary and sufficient for being a bachelor. All right. And then Q is necessary and sufficient for P. Being a bachelor is necessary and sufficient for being an unmarried male. Okay, they can all be symbolized using these symbols over here. Okay. All right, so statements of symbolic logic. All right, so we've got 3 columns again. So we've got negation, so that's this symbol. That means not P, or it is not true that P. Okay, these are 2 statements that you can use to do negation, not P. Conjunction and P and Q, P but Q. All right, so, and then there were some more in that table. Okay, these are just little simple examples, just kind of like a little review, an overview of everything. And then we've got disjunction, P or Q. That's what it means, P or Q. And then we've got conditional, P, if P, then Q. So if P, then Q. P is sufficient for Q. Q is necessary for P. Okay, we saw that in those tables that we did earlier. And then we've got biconditional. So P, if and only if Q. P is necessary and sufficient for Q. And once again, we just got finished reading that table that has a few more in there. But that's what you've got here. You've got negation, conjunction, disjunction, conditional, and biconditional. Okay, that's how you can refer to these. All right, so let's look at this example. So let P and Q represent the following simple statements. She is wealthy, that's P. Q, she is happy. All right. Write each of the following symbolic statements in words. So they're giving us the symbols, and we've got to do it in words. So we're doing it backwards. All right. All right, so look at this. We've got not, okay, that's the negation. So not, and then in parentheses, we have P and Q. So how would we write that? Well, the negation part, that would be it is not true, right? It is not true that what? It is not true that what? Well, she is wealthy and she is happy. She is wealthy and she is happy. All right, so remember this. That's this. She is wealthy. That's P. She is happy. That's Q. And then we've got the and here. Okay. So how could we go about writing this as a statement? We could write, we probably wouldn't say it is not true that she is wealthy and she is happy. We could write what? It is not true that she is wealthy and happy. Okay. All right, so you would have something like this. And then, just for fun, you could also, there's a couple other ways you could write it. So you could also write, it is not true that she is both wealthy and happy. You could insert the word both there. So you could insert the word both. You could leave it like this. That would be fine. I mean, technically that's not wrong, but try to simplify these things as much as you can. Okay, that's what That's what I would recommend. Try to simplify them as much as you can. All right, so what about this one? Not P and Q. So not P, well, what does that mean? That's she is not wealthy, right? That's not P. And then we have what? And. That's that symbol there. And then for Q, she is happy. All right. So she is not wealthy and she is not happy. And, you know, I wrote it up here to see maybe if we could write it again, you know, kind of write it in a little simpler form. But, you know, looking at this, I don't see any other way to write it. She is not wealthy and she is happy. All right, so that's really about all you're going to do with that one. Okay, so now let's look at the next one. And I know this right here can seem kind of confusing, but I mean, you've just got to kind of think about it a little bit. All right, so what about this one? Well, that's what it is not true that's this little negation symbol here. And then what do we have in here? P or Q. P or Q. So that is what? She is wealthy or symbol. Okay, so I wrote P and then I wrote or, and then Q, she is happy. Okay. So I just kind of sketched out what that's saying. Now, what else could I do to rewrite that? Well, I could write what? It is not true that she is what? She is wealthy or happy. See, I don't need to put she is wealthy or she is happy. I can leave out this she is. So I could write it like that. What would be another way? So remember what we're trying to say here, that she's not wealthy or happy. So we could say what? She is neither wealthy nor happy. Okay, so you know, this one or this one. Okay, I would feel for sure probably this one would be the more common one that a teacher would see from a student on a test rather than this one, but either one of them's fine. Either one of them's correct. Okay, and you know, just don't get frustrated doing this. Just work the problems, practice them, and you know, you'll start seeing the things. All right, so let's see what do we have here. All right, so sometimes they contain more than one connective. Okay, so when we express these things symbolically, parentheses are used to indicate which simple statements are grouped together. So when expressed in English, commas are used to indicate the groupings. So here's a little table that shows the groupings using parentheses in symbolic statements and commas in English statements. All right, so we've got the symbolic statement here, okay, P and not Q, or you could read it as if P and not Q, then not R. Okay, so the statement that's grouped together is this right here in parentheses. Okay, so if Q, okay, if Q and not P, comma, then not R. All right, then not R. So what do we have here? Q and not P, not R. If not P, then not R. So the part that's grouped together is what's in parentheses here. Okay, so it's like this one's grouped by itself and then this one. So how would we represent that? Well, Q, comma, and if not P, comma, then not R. Now this comma here, that right there is for the if then. Okay, when you do like if P, comma, then Q. All right, that comma is just for that. That's what that's for. This one right here is showing the separation between the groups. All right, so you've got that. So let's take a look at some examples. So let P, Q, and R represent the following simple statements. P, a student misses lectures. Q, a student studies. R, a student fails. All right, and we want to do Q and not P, and then not R. So if Q and not P, then not R. All right, so what do we have here? All right, so we've got Q and not P. So there's Q. So if a student studies and, okay, I'm just writing out what this is saying. Okay, that's all I'm doing. And then I'll go back and look and see if there's a way that we can maybe simplify the statement. Okay, so first, just write out what you've got. So if a student studies and a student, not P, a student does not miss lectures, and a student does not miss lectures, okay, comma, then we've got what? Not R. A student fails is R, but we've got not R. A student does not fail. All right, so how maybe could we rewrite this? Well, if a student studies and a student does not miss lectures, so maybe one way to rewrite this is maybe just leave that out. So if a student studies and does not miss a lecture, then the student does not fail. Okay, so I'm not going to rewrite it. To rewrite it, just take out the word student. Okay, so that's how I would rewrite it. And that's kind of similar to what we did before with the she. We took the she was there twice, like she is wealthy and she is happy. And we just wrote she is wealthy and happy. Okay, we took the she out. All right, so what about this one? Part B. So let's look at this. Q, well, what's Q? A student studies. So let me write this, change color. A student studies, okay, comma, and, see, comma, that's separating it, and then we've got this, if then, okay, if a student does not miss a lecture, does not miss lecture. All right. Then, right? Then a student does not fail. Okay. And one thing to notice here, the if then, you can separate it by a comma or not. Okay. So notice I didn't put a comma here, and that's fine. So here, how could we write this? We could write a student studies, right, comma, and what? If a student does not miss lecture, does not, if a, and if a student does not miss lecture, okay, then the student does not fail. Okay. So I just cleaned up what I wrote. You see, I changed the A to the. So if a student does not miss a lecture, then a student does not fail. So I wrote, if a student does not miss the lecture, then the student does not fail. That makes more sense. See, just remember, this first thing that I write right here, I'm just writing out what that says and writing down and rewriting these statements down. And then I'm going back and rewriting it to make sense. Okay. All right. So now we've got dominance of connectives. So the dominance of connectives used in symbolic logic is defined in the following order. So if you have something written out and it doesn't have parentheses grouping things together like that. So in order, we've got negation, we've got conjunction and disjunction. Those are the same. And then we've got conditional, biconditional. Now, keep in mind, this is least dominant to most dominant. Okay, so this is the most dominant here. This is the least dominant up here, as far as, the order that you do. So using the dominance of connectives. So if we have this statement here, okay, here's your dominant connective. All right. So we would have P, this, and then we would group these together. Okay, you would group this last part together. Same thing here. Here's your dominant one, so you're going to group these together. And so here you've got your dominant one here. Remember, this is dominant over this one. And so you're going to group those together. And then for this one, you're going to group the first two together. And then as far as these go, well, look at that. There's your dominant one right here. I've got it written down, then I've got it written with the dominant one in color. Let me maybe do this. This is like having 3 columns here. Okay. And see, in the red, it shows the dominant, so I'm going to group those together and group these together. And then these have the same level of dominance. Okay. Remember, the and the or connective, they're the same. Okay, the meaning is ambiguous. All right. So, like as far as this one goes, you could have this in Q or R. So you could have this, or you could have that. It doesn't matter. Okay. All right, so let's look at this. It says write each compound statement below in symbolic form. Okay. And this is actually our last example here. All right, so let's go ahead and write these. All right, so I forgot to write the statements, what P, Q, and R were. All right. So now let's look at writing these symbolically. Okay. So it says, I do not fail the course if and only if I study hard and I pass the final. All right. So let's see. This first statement here. Okay. That first statement, which one is that? That is what? Not P, right? I fail the course. I do not fail the course. That's not P. And then we have our if and only if. There's that symbol. I study hard. So I study hard. That would be what? Q. And, so there's that connective, and then we've got I pass the final. That would be R. Okay? That would be R. So that's what? Not P, if and only if, and then we've got Q and R. Let me write that a little bit better. Okay. All right. So the most dominant connective that we have is this one right here, the if and only if. So what would the symbolic form be? Well, the ones afterwards, right? You see that? See when we had, let's see, which one would that be? That's this, and then we've got the two behind the if and only if. So see, we've got something like this, if and only if, and then we've got the two or whatever it is. See how these are in parentheses? That's what that is. Okay. Now, what about this one? I do not fail the course if and only if I study hard and I pass the final. Now, you might be looking at this problem here and thinking, that's the same thing we just did. But it's not. Okay? So, let's look at this. All right. So, we know from before that is not P. This is our if and only if, right? I study hard. That's Q. There's our connective and. I pass the final. That's R. Okay? So we've got not P, if and only if, and then we've got Q and R. All right? So now let's look at the grouping. Look at that right there. The comma. Notice this one doesn't have a comma. Okay, it doesn't have a comma. So this comma here tells me that all this before the comma is grouped together. So there you go. So you've got to be careful. You've got to watch. If it has a comma, if it doesn't have a comma. So look at that kind of stuff. And look there, that's the last one. So that video was kind of long, but hopefully it helped. I hope you feel smarter after watching it. I hope you don't feel more confused. But you know, this stuff right here, it can get kind of difficult. But you've just got to go through it, and you've got to practice these things over and over and over. Don't let it get too confusing. Don't try to think about it too much. Don't make it more complicated than what it is. All right. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.